Okay, so here we go. We're going to be looking at the massing tool set tonight, and we'll be looking at in-place families. So there are two parts of Revit that allow custom modeling to be done, and we're going to look at both. Now, some of the different applications for in-place families are just at the top of the first page of your notes there. Walls that are on an angle, so that means they're not vertical, they lean in one direction. That's where you might need to use an in-place family or the massing tools. Any architecture that curves in more than one direction, so if something gets curved in plan and also curved in profile, you will need to do either massing or in-place modeling. Curved and sloped floors. So like an auditorium or an arena, those floors would have to be modeled as an in-place family. Oftentimes modeling of decorative structure, especially if it's a one-off thing like a trellis, that can be modeled as an in-place family as well. So let's look at the process of getting into this in-place family modeling mode. So on the architecture tab, in the component menu drop-down, you can see that there's model in place. Now, as we get into in-place modeling, here's the thing. If you're going to have more than one of whatever it is that you're planning to build, so i.e. more than one copy, don't make an in-place family. At that time, what you should decide to do instead is go and create a new family from an outside template. So that means build whatever it is outside the project and then bring it in. But if you are truly doing something that needs the context of the project for you to build it, so a good example would be a large fireplace. So if you're doing a big, like a guest lodge or something like that, and there's going to be a fireplace that's going to be built in the middle of it, that is an excellent use of the in-place family tool set. So you go to the component menus. If you folks want to do that, just grab the model in place tool set. The next thing that Revit asks you is what category is this in-place family going to be? Now, if you choose something now, you can always come back and change it later. So don't worry about, maybe choosing your own category. So for something like a fireplace, that would fall under the category of generic models. And so once you've chosen the category, go ahead and hit OK. Revit will then ask you, what's the name of this family? So if I say, it's the fireplace here, this will become a family entry in the project browser. So you folks can hit OK. What I'm going to do here is I'm just going to back out and go down to generic models. So you can see there's different families that are there right now. So when I start up the in-place family command and I choose the generic models category, as soon as I put in the name of the family, it's going to show up in the list here under generic models. So when you're looking in the project browser, it doesn't distinguish between in-place families and families that you've loaded from outside. They both list in the same set of folders. So as soon as I hit OK here, there you go. You can see fireplace there. There's no little plus beside it because it's just a single in-place family here. So now let's have a look at the ribbon. So we have all of what we call the primitive modeling tools for making the basic kinds of geometries that Revit can build. So we've got extrusions and blends and so on. So here we'll just we'll take a quick stab at just doing something basic here. So if I want to do a little, the bottom of this thing for the firebox, so something maybe 10 feet wide and 4 feet deep or something like that. So of course you can put dimensions on it and size it. So here's our extrusion. I'll make this part of the firebox 7 feet tall, and I'll finish. So when we go and look at this thing in 3D now, there's our first extrusion. So we're not using walls, we're just building with solids. So with this tool set, that you'll notice that there's solids and there's also voids. So if you want to cut a hole out of our fireplace here with a void, it's just like solid modeling. So you can mix the solids and voids up, and the voids will cut holes in the solids. So I've started up the from the crate tab. From the void form drop down, I chose void extrusion. So what I'm going to do here is just draw out the shape. I'm not going to worry about being too accurate here. So here's my firebox, and now I'm drawing a void that's going to cut a hole into that firebox. Don't want it to be 7 feet tall, I'll just make it 4 feet tall. And so once I hit the green check mark here, this will make a 4 foot tall void inside the solid. So look at it in 3D there. I'm just going to turn on shading. So there you can see there's our firebox. So for doing things like the mantle on top, one of the things that you'll use quite a bit when you're building families, whether it's an in-place family or a component family built from one of the family templates that we'll get into next week. On the Create tab, find the Set Work Plane tool. Now, in the next few weeks, we're going to show you how to use reference planes for doing modeling. So you can have different geometries that are built on different work planes. We'll be doing that actually in a few minutes tonight. For those of you who've done some modeling in SketchUp, you know how you can kind of put your cursor over the top of something that you've extruded, and it'll set your working plane to that face, and then you can draw your 2D shape and use the push-pull tool to pull it up. Revit wants you to be a little bit more explicit or intentional with where you are working. So on the Set Work Plane tab, if you folks grab the Set Work Plane tool, Revit says, okay, what's our working plane going to be? Now, as we'll see in a few minutes, often we will name a reference plane, and a reference plane that's been named will show up in this list. But for right now, just choose pick a plane. So I'm here in a 3D view, so I can look down on the top of the geometry that I've modeled so far. Architecture set, pick a plane, hit OK. So now what you do is you put your cursor over the edge. So you can see it's being highlighted blue there. Just as I hover on each face, I can choose which face I want to start modeling from. And I want to model from the top of my fireplace here, so just click. And just to confirm, you can hit the Show Work Plane, and it shows in blue what your current work plane was. So it was level 1 before, now we've changed it up so that we're going to be extruding off the top of this fireplace. So what I'm going to do here is I'm going to do sort of a tapering stone element on the top of this thing. And so if you folks go over and grab the blend tool, this allows us to choose two shapes. So we'll have a wider shape at the bottom and a narrower shape at the top. So we can build this stone tapered piece for the flue as the chimney tapers up towards the ceiling. So choose the blend tool. So blends are a two-stage process. You draw the shape for the bottom part of the blend, and then over a linear distance, this geometry will morph, change shape into the top sketch. So watch on my screen here, and I'll walk you through it. Okay, so what Revit is asking here is for the bottom part of the blend. So I'm just going to draw a rectangle here right on top of my fireplace. That blue plane, remember, that's just confirming your work plane. You can turn that off. So it just shows you where you're working from. So that is the bottom of this blended thing. and I'm going to make them so that they're 10 feet apart. So we're at the first end right now, and when we draw the second end, whatever we draw, that shape is going to be 10 feet higher than what we're looking at right now. So with the blend tool, you switch between top and bottom. So we've finished editing the base. So now when I hit edit top, I'm supposed to draw what I'm going to put on here next. So I'm going to turn that show work plane off, and I'm going to click the top of the view cube so I'm looking straight down my geometry here. And again, I'm not going to worry about doing this exactly to size here. But that's the top shape. So it's going to morph from the bottom rectangle to the top rectangle over a 10-foot distance. Now Revit draws both of these rectangles on the same plane initially, and it's not till you finish that you see the resulting geometry that you get. So with the in-place families, you build geometry with a combination of solids and voids. You can have your voids interacting with the solids, and then you, once you're done, you hit Finish Model. And so now Revit treats all that geometry as a single family. Now you can see that there's drag handles on it all over the place. And yes, you could change the size of that geometry just by dragging those handles up and down. Sometimes you'll do it inadvertently, right? Like you drag on a handle when you're editing something else and you accidentally change the size of your in-place family, which is kind of annoying. Now, if you do want to get in and start working on your in-place family again, you'll select it, and then up on the ribbon you folks can see Edit in Place. So once you finish your in-place family, it takes you back to the standard Revit tool set. When you are editing or creating an in-place family, it gives you this particular set of tabs on the ribbon, which is called the Family Editor. So the Family Editor is a separate set of tools that's used when you are building family geometry instead of working in the context of a project. So as soon as we go back into this in-place family, all the different tools that we were working with originally come back to you. So that is a little sort of a preview of in-place families. So often with in-place families, people, different firms around town are bringing geometries in from outside of Revit because they really like the modeling tool set in that particular software, notably Rhino. So Rhino is used by the sort of different marquee architects in town here like Bing Tom and others to create more difficult geometries that Revit does not readily create, although as we will see, Revit can create some pretty fantastic geometries. So in that case, what you can do in the context of an in-place family is import some geometry from outside of Revit. So we're gonna look at that in a few moments. In the process of working on an in-place family, other things that we will add. So here I'm inside editing my in-place family. So if you look on the set of steps in the bottom of the first page of our notes. So we choose the category. When you start the in-place family command, and I told you that you can change the category after the fact. You're not married to the particular category that you chose initially. When you're editing an in-place family, at the top left corner here, we've got the family category button. It's the one with the yellow folder on it. And when you click on this folder, you can change the category of your in-place family. So if you're like, oh, you know what, this isn't going to be generic models. I'm going to have my fireplace made by the millwork guys. Obviously, that doesn't make much sense. But if you want to, you could choose it to put it in the casework category. And what would happen is as soon as you hit OK, Revit will now list this thing in the casework category instead of generic model. You can see it move from down here up to the casework category. So as soon as you change the category of an in-place family, Revit moves it into the appropriate folder inside your project browser. There are different, behaviors of categories, notably graphic behaviors, and we'll get into those in the next few weeks. So putting it on the right category does matter. Now, if you're not bringing geometry in from AutoCAD, typically we will use reference planes. And as we're going to see, reference planes are really, really important to family building. So reference planes are as important to your families as levels are to your project. So on the next quiz, or on the final exam, I can't remember, it's going to ask you what's the most important organizational element inside a family, whether it's an in-place family or a family built from a template like a new door. The answer is reference planes. So we're going to show you that right now. So on the Create tab, close to where we had the Set Work Plane tool, is the reference plane, or reference plane. Now you folks might have used these in your projects. They're like an informal grid. So here, in elevation, if I draw a reference plane, I can use this as the starting point for some of my geometries. So here, if I want this to be, say, I'll make it 7'6" above the floor. So in my elevation view here, I just switched to my elevation view so I can be looking horizontally at my fireplace. When you add a reference plane from the Create tab, and you name it, named reference planes can be used by the Set Work Plane command. Now the deal is, if you want to use a reference plane, you can't be looking at it sideways. You've got to be looking at it perpendicularly. So this reference plane, I'm not going to be able to work on that reference plane from this view. I'll have to switch back to my plan view or my 3D view, either way. So I can't be looking at a reference plane sideways. Now, because I've named that reference plane, when I go to the Create tab and I click Set, that reference plane appears. Now this would also show you reference planes just in your project that you created before the in-place family. If they were given names, they'd show up in this list as well. But if you create a reference plane inside an in-place family and name it, you'll see it in the Set Work Plane dialog box. Now, as soon as I hit OK, there we go, you can see that the work plane is now higher than it used to be. And also, by the way, there's these drag grips on here, so you can kind of make the visible part of the work plane, the visible sort of little shaded blue graphic that you get here. This blue graphic doesn't really matter how big it is. It doesn't matter if it's like this or like this. It doesn't matter if it's like this or like this. Revit is just giving you a visual confirmation of what you're going to be building your geometry from for the next modeling command. So when we use the Set Work Plane command, we're just saying that's going to be the starting point for whatever geometry I build subsequently. So if I were to go and build another extrusion now, it will be extruded from that reference plane. And in fact, so I've just tiled my views here so we can kind of see a bunch of stuff at once. So here in my elevation view, I'm going to take this reference plane and just nudge it up and down with the arrow keys. And you can see what happens with that solid I created. It's hosted by that reference plane, and as that reference plane moves up and down, so does that particular solid. And then in elevation here, you can see I've got my, my original bottom of my blend here, and I can pull that up and I can snap it to the reference plane and lock it. So now that blend, the bottom of that blend is now associated with that reference plane, and as that reference plane moves up and down, you can see that the bottom of the blend moves with it. So there's a certain stickiness that we get with these geometries, and reference planes are kind of meant to be the skeleton that allows all this stuff to move. So reference planes are super important. And step 5, so you've seen how we've used the join or the cut geometry with the void intersecting the solid, but we'll have another example of this in a few minutes. Okay, so I'm going to finish this now, and we're going to go over to the next page here, and we're going to work on one of these in-place families together. So if you're done with your fireplace here, I'm going to delete mine, and you'll see that it will disappear out of the project browser. So I finished the in-place family. I'm back to the regular set of tools in Revit. So I can just select that thing and delete it. So it's gone. So we're going to go back to the floor plan view here, and we're going to go through the steps on page 2. So here we're going to make a desk that's got some scallops cut out of the bottom. Now, like I said, if you're going to have more than one of these desks in your project, build it outside of the project, and we'll show how to do that beginning of next week. So for now, we're going to go into the model in place drop down here again, and this time we are choosing casework, and this is top bullet point on page 2. All right, so we'll hit OK here. So now we're going to call this, as it says in the notes, reception desk. So you might be doing this in the middle of a floor plan. So there would be walls, presumably in the area where your reception desk is placed. So you kind of build this thing roughly where you want it. You can move it later, of course, but you got to start somewhere. So what we're going to do here is we're going to build the extrusion for the valance. So here we go, and the middle screenshot there where it shows a radius of 6 feet, that's for the 180 degrees of arc. So we're going to use the arc tool here, the 3-point arc. And it doesn't really matter exactly where you draw it. I'm just going to draw it in the center here. And so I'm going to draw this thing. Now you can see that was my first click. I'm going to come over 12 feet. That's going to be my second click. So my third click is I'm going to come down and ask for 180 degrees of arc, and you'll see that it'll snap to it very nicely. You can see the temporary dimension up on the screen. We're getting a 6-foot desk radius, which is what we are after, so go ahead and click. Now rather than drawing another arc, we want the valance to be 3 inches thick. So we'll go up to the offset command and give ourselves a value of 3 inches in the offset box. So go grab the offset command, give it a value of 3 inches before you go into the screen, and offset that curve inboard. So you'll have 2 arcs like you see on the screen. Now we need to make this a valid sketch, so we have to cover off these 2 pieces on the end. So we're done with offsetting. Go up and grab the line tool, and we'll zoom in here, and we're just drawing a horizontal line across between these 2 end pieces here, and then do the same on the other side. So that is what you should see. Now Revit will remember the last settings you gave for the extrusion. So here it's remembering the 0 and 4 feet that I did earlier when I was making the fireplace. In this case we want to make a 30-inch desk, so we have 1.5 inch thick counter. So this means that the valance goes up to 1.5 inches below 2'6", which is 2'4½". So in the properties palette, find the extrusion end parameter and put in 2 space 4.5. Revit will interpret that as 2'4½" inches. Now, I'm going to finish this sketch. I guess actually you folks can too. When we look at this thing in 3D, just go ahead and click on the doghouse icon there. What we want to do is to assign a material parameter to this solid, so that people who are using this desk in a rendering, when they've got a camera that's looking at the desk, they can change its appearance. So we're still inside our in-place family here, but you can see the model right now, or the valence is just a dull gray color. So if you select it, what we are going to do here is we're going to change its material. Now here's the thing. You can see that there is a material parameter here, and you can see it says by category. Now don't do this. I'm going to show you this. I could just click here in the material parameter, and there's a little button with 3 dots on it that would allow me to pick a material that's been defined in this project so far. So I could come in here, open up the material dialog box. Again, don't do this yourself. I'll just grab some kind of wood here, say cherry, and hit OK, and done. So you can see it's changed its material. And if we went to render it, it actually wouldn't look too bad. So why not just, give it a material? Well, the reason is that someone would have to come in and change this, edit the in-place family, click this particular solid, and change its material setting. Now, talk about splitting hairs. There's 2 buttons here, folks. This one brings up the materials dialog. The one next to it, that little gray button on the right, and we're going to be clicking these little gray buttons a lot in the next couple of weeks. This allows you to create a parameter that will control what this thing will render like. And you can give it a friendly name that people will see, and they can say, oh, that's the valence material. I want it to be some other species of wood or some other finish. So when you hit that little gray button, it pops up this dialog box here, and if there were any previously defined material parameters for rendering purposes, they would show here. There aren't any, so we have to click this button at the bottom, and this will allow us to define a name here. So we can, this is going to be our valence material. And we'll see in a few minutes why this is a good idea. So go ahead and call it the valence material and hit OK. Now after you have created the valence material parameter, it now shows up in the list, and we can hit OK to choose it. So now, this particular solid is going to use, and you can see that there's a little equal sign here. And so what it's saying is, this particular solid is being driven by this valence material parameter. So we're going to carry on. I'll come back to this in a bit. Now don't finish the model. We're going to go back to the plan view here, and we're going to build the countertop. All right, so off to the Create tab. So on the Create tab, we're going to make another extrusion. Now, what's going to happen is that our counter is going to overhang our valence by 3 inches. So here's the pro tip. I'm just going to use the pick tool. There is the pick tool there. You folks can see that. And with the pick tool, we're going to offset 3 inches. So what this means is, in the process of creating this extrusion, when I use pick, I have an offset of 3 inches here. And when you put your cursor on the outer edge of the desk, the line it's going to generate will be offset 3 inches from the face of our geometry. And there it is. So that's going to be the outer curve for our desktop surface. So desks are generally 2 feet deep. So instead of trying to figure out how much we need to offset on the inside, you know, using the pick tool, we can just use the offset command. And in this case, we're not offsetting 3 inches like we did before. We are going to offset 2 feet. So of course we're going to offset that curve to the inside, like so. So this is our desktop working surface. We need to draw those 2 lines across the top. So go back and grab the line tool again. So now, right now, everything that we are modeling in this desk is relative to level 1 in a project. So if I was building this on level 2, it would be modeling all of this desk geometry with respect to level 2. Now, desks, counter surface, 2'6" high, right? So it's going to end at 2'6". So that's our extrusion end value. But it's going to start at the top of the valance, which is 2'4.5" above the floor line. So it's starting at 2'4.5", and it's going to 2'6". Could you reverse those values? Absolutely, no issue. So there's no difference if I put 2'4.5" in here and 2'6" here. No difference. Now, like last time, we are going to go to the material row here and hit the little gray button on the far right-hand side. Now you can see the valence material is already listed there, right? So that material parameter is already there, ready to go. But we're going to create a new one at the bottom here. This one's going to be called counter material. Okay, so once you folks have done that successfully, hit the finish check mark, and now you can go look at this thing in 3D, and there's the 2 pieces so far. Now, why are we making these material parameters? So once you folks have got the valance and the counter modeled, and you finished all the modeling, up on the ribbon you folks can see Finish Model, the green check mark. Go ahead and click that. And of course it takes you back to the standard Revit interface with all of the different tabs on the ribbon. What I want you to do now is just click once on your in-place family. So let's say that you want to change the appearance of this desk. Rather than going in and choosing Edit in Place, which you can see up here on the ribbon, and doing that stuff, you can go to the Properties palette, and this is just like when you folks are working with doors or other families that you've loaded into your project. Go to the Type dialog box here, hit Edit Type, and look at that. There's those material parameters. So what I'm going to do with my counter material here is I'm going to go into the material row here, and I'm going to click the little button here with the 3 dots on it, and I'm going to find concrete. So let's type in concrete at the top. So just grab one of the concrete materials, it doesn't matter which one. Hit OK, and OK. So in realistic mode, if you folks choose realistic mode, you will see kind of a pre-rendered rendition of your desk, kind of showing how those materials would look if they were rendered. So that's why we add those parameters, because otherwise what someone would have to do if they wanted to change the way this desk looked, they would have to select the desk and then choose Edit in Place, and then they would have to choose one of the different solids that have been modeled, like the counter, select it, go into its material parameter here, and hit the little button with the 3 dots on it. Now right now you can see we can't control it that way because it's being driven by this material parameter. Incidentally, while you are editing an in-place family, any of these settings that are being driven by parameters you've created, they'll show up in this dialog box here, which is underneath family category. It's called family types. So in here, you can see the materials that we listed, and you could change them here as well. So you can change them outside of the in-place family or inside. Now, what I want you folks to do right now is we're just going to look at how you can change the parameter names and some of their settings. If you put your cursor on one of the rows here in the family types dialog box, so that's the dialog box with the 4 blue squares on it. This is an important dialog box, more so when you're building families from scratch inside a family template. But here in the context of a project, an in-place component, or an in-place family rather, you can rename, down at the bottom here there's an edit button. You can rename parameters if you've misspelled them. But what we're going to do is we're going to click on one of our parameters here that we've just created and edit it. So this is the edit parameter dialog box, which allows us to go in and respell a parameter that's been named incorrectly. But what we're going to do here is we're going to change it from a type parameter to an instance parameter. So again, put your cursor on one of these rows, go down and hit the little pencil icon on the bottom left of the family types dialog box, and once you get in there, change it from a type parameter to an instance parameter. Hit OK and then OK. Now we're going to show you what this will do. When you hit Finish Model, what we're going to do now is click on our in-place family that we just finished. And I want you to notice that this one material is showing up straight away when you select our in-place family. Why is it showing up now? Because it's been made into an instance parameter. So instance parameters appear straight away when you click on an object. Type parameters, they show up when you select an object and then choose edit type. So we left this one as a type parameter. Now, I've told you folks that if there's going to be more than one of these things that you're building, don't do an in-place family. So if that's the case, do we ever need a type parameter for an in-place family? No. They could all be instance parameters. So we really could go back and edit our in-place family, roll on over to the family types dialog box where we can rename parameters. We'll talk about this dialog a lot more in the next couple of weeks. You'll notice now that Valence material has the word default after it in brackets. I wish it said instance. So red is just telling you that that is now an instance parameter. So if you click on the counter material parameter now, just put your cursor somewhere in this row. And if you go down and hit that pencil icon and turn it into an instance parameter as well, and then hit OK, counter material will also be shown with the word default after it. So these are both instance parameters, and so when we hit OK, and if we were to finish the model, we would see that they are both there right away when we click on our in-place family back in the project. So now what we're going to do is we are going to add the bars that you see at the top of the page there, and then we'll put the scallops in, and then we'll take a break. Okay, so let's go back to the level 1 plan view here. So we're now looking down on top of the desk. Oh, but it says in an elevation views. Okay, so you need to be inside the in-place family. We'll go to the south elevation here. So there's our desk. So under create the bars, in an elevation view, create a reference plane. So that's from the create tab. There's our reference plane tool. Don't use reference line, use reference plane. So we're going to make a reference plane that is 2 feet-ish, 2 feet above level 1. So here you can see after I put in the reference plane, it shows a temporary dimension. Click on that temporary dimension and make it 2 feet. Now, it says call the reference plane top of bars here. So you can see where it says click the name. Call it top of bars. You don't have to follow the exact notes in terms of the naming of these things. It doesn't matter. You just want to make a reference plane name something that will make it recognizable so that you'll know the reason why you put this thing into your family. So again, can't model on a reference plane that we're looking at sideways. So we need to go back to the plan view so that we can look down on this reference plane and do some modeling. So back to the create tab, and we are going to use the set work plane command again. And this time, top of bars will be in the list because we just created it and named it. So it's showing up only because it has a name. And hit OK. So what this is going to do is to ensure that any geometry that we make is going to be in this reference plane. So if the reference plane moves up or down, that geometry will move with it. So level 1 plan view. Now we're going to do this time a sweep. So from the create tab in the plan view, choose the sweep tool. Now there's 2 different directions that you can go with a sweep. Now up on the ribbon there you can see there's sketch path and pick path. Now regardless of which choice you make, the construction of a sweep is a 2-step process. Number 1, define the path for the sweep, and number 2, define the cross-sectional profile. So sketch path and pick path are both options for step 1. Now, if you folks keep your eyes on the screen here, I'm going to walk you through what these mean. Now, pick path is a different animal because what it does is it allows you to pick the edge of pre-existing geometry so the sweep will follow those edges. Now, the funny thing about the pick path tool is that it will allow you to make a sweep follow edges that can be on more than one plane. Now, what do I mean by that? So again, don't do this, just follow me here and I'll talk to you what's happening here. So I'm using the pick path tool. We're not going to do this as a class, but I just want to explain it. With the pick path tool, you literally pick the edges of pre-existing geometry. So that's where the sweep is going to go. Then it's going to go down the edge of this desk here. And then I'm just going to orbit around and the sweep is going to go over here and then follow the inside edge of this. So all these different pink lines, they're on different planes. And only the pick path mode facilitates this. So when I hit finish here, there's step 1. So I've drawn the cross-sectional profile of the path, and then I'm going to draw the cross-sectional profile. And so here you can see that profile is kind of going all over the place. So this technique uses pre-existing geometry. Now I'm just going to delete it here. Now here's the sketch path tool. Now with the sketch path mode, the path is only in one plane. And remember that we use that reference plane as our path. So if I go and draw, or use the pick tool here, and pick the front edge of this desk and then this edge here, and finish, when we go look at this thing in 3D, you can see the line is not at the edge of the desk. This is the path for the sweep. It's on that reference plane. See, there it is. It's on that reference plane. So pick path, the lower of those two tools, this one here, picks existing 3D geometry, whereas sketch path, you just draw it, and it's going to stay on the reference plane that you chose prior to starting the sweep command. So that's the one that you folks are going to use. So from the level 1 floor plan here, choose sketch path. And what we're going to do is use the pick tool and turn on lock. Now what this will do is that if the radius of the desk were ever to get larger or smaller, the path, so here if I use the pick tool with lock enabled, the path will stay locked to the outer edge of the desk. So if the desk changes radius, this path will change radius, but it's still, the path itself is still going to be on that reference plane because we used the set work plane tool to make the path live in that plane, the top of bars reference plane. So step 1 is creating the path. So that's it. Done. So when you look in plan, you'll see a black line. Now if we go to the 3D view and orbit around here, so shift and then your wheel mouse, what you're going to see here is a pair of dashed green reference planes that are intersecting. They're not actually reference planes, but they're dashed green lines that are intersecting with a red dot in the middle. This is called the profile plane. So it is here where we draw the cross-sectional profile that's going to be swept along that black line. So what we are doing is this. We're now done with the path. What we're going to do now is we're going to draw the profile that's going to be swept along that path. So choose select profile. And we're going to do it by sketch. Now, we'll talk later about how you could load a profile family in. That'll be a couple weeks. What we're going to do now is draw the cross-sectional profile that's going to be swept along that path. So choose edit profile after you've chosen select profile. So select profile, edit profile. And now we're going to draw 3 little circles. Now they'll be kind of hard to see, so if you go to the View tab, turn on Thin Lines. This will just ensure that you'll be able to see these circles clearly as you draw them. So on the View tab, turn on Thin Lines, and then back to the Edit Profile tab. And we're going to zoom in pretty close to this dot here. And I'm just going to click on the red dot here, so that's the center line of the sweep path. And I'm going to draw a 1/2 inch radius circle. So just click and drag, makes your radius 1/2 inch, hit enter. So now this circle will be swept along the path. All right, let's hit escape twice, so we're no longer drawing circles. So you're going to have that one circle sitting there. So now zoom in and select that circle that you have just drawn. So once we've selected that first circle, go over and grab the copy tool off the ribbon. Make sure that the multiple mode is selected before you continue. So select the circle, select copy, select multiple. Click anywhere on your screen, doesn't matter where, and drag straight down. Make sure you're not on an angle, straight down, 3 inches. Then we need to make one more copy, so again, make sure you're dragging straight down from your copy here. Straight down, 3 inches again. and then hit escape. So what's going to happen is that those 3 circles are going to be swept along our path. Now before we get there, we're going to go over to the material parameter, hit the little gray box on the far right side, and we're going to add a new material, which in the notes it says bars material. So down at the bottom here, adding a new material parameter. And like we talked earlier, this is going to be, this is a one-off desk. So as a result, it doesn't need to be a type parameter. We could make it an instance parameter. Now that's not in the notes, but we know now that if it's an in-place family, you might as well make the parameter an instance parameter, and we'll call it bars material. Hit OK, and then OK again. There we go. And then we'll finish the sweep. Hit the green check mark again. And you should see those 3 bars. Okay, so we'll take a break here for 10 minutes. Any of you who are having some troubles with the bars here, we'll give you a hand.